All right, we're going to jump into equations 2. Again, just solutions for that. So a ball is thrown straight up in the air with an initial velocity of 63.7 meters per second. So thrown tells me that we're talking about free fall. So right away, I know that my acceleration is 10 meters per second squared down, because every time we have a free fall problem, that's our acceleration. The initial velocity is 63.7 meters per second, and that's up. So what we're going to have to do, because the 10 is down, is make the acceleration negative. That's huge. I also know that the time is 3 seconds, and in part A, my unknown is the final velocity. Well, that's just going to be velocity, time, velocity, and acceleration. Velocity is equal to the initial velocity plus acceleration times time. So that final velocity is going to be 63.7 meters per second plus negative 10 times 3, because it's negative 10 is the acceleration. So that gives me positive 33.7 meters per second as my final velocity. Means it's going to be up. What's its position after 3 seconds? Well, with this, we have all of the information except for position, so we can say change in position is initial velocity times time plus 1/2 acceleration times time squared. So that change in position is going to be 63.7 meters per second times 3 seconds plus 1/2 times the acceleration, which is negative 10 meters per second squared, times the time of 3 seconds, whole quantity squared. And it's super important that you put the negative 10 in when you use your calculator, and it's super important that you put the squared in. So delta x, when we plug all that into our calculator, comes out to be roughly 146.1 meters. Now, how long does it take the ball to reach its maximum height? At this point, we're talking about a different spot. Parts A and B, we're talking about 3 seconds, which is somewhere on the way up. Parts C and D are talking about the maximum height. At the maximum height, again, I still know that we're in free fall. So my acceleration is 10 meters per second squared down. But at the maximum height, my special piece of information that I have, velocity is equal to 0. So the final velocity is 0. The initial velocity is still 63.7 meters per second up, means I have to make that negative 10 meters per second. And part C is asking for the time. So I've got acceleration, velocity, velocity, and time. If I want to solve for the time, I've got v equals v0 plus acceleration times time. So v minus v0 is equal to acceleration times time. Just subtracted that over. So divide by the acceleration. And my time here is going to be final velocity 0 minus the initial velocity 63.7 divided by the acceleration negative 10. That time comes out to be 6.37 seconds. What's the maximum height of the ball? We're still talking about maximum height, so all this is still true. We can solve this lots of different ways. I prefer the one that requires no algebra, just putting it into the calculator. So 63.7 times 6.37 plus 1/2 times negative 10 times 6.37 squared. Plug that in, and for our displacement from our calculator, we get 202.9 meters. I realize I'm going fast through this, but you can pause the video. What's the ball's speed when it's at an elevation of 100 meters? This is yet again a different place. Still know that this is a free fall problem. 10 meters per second squared down. I still know that the initial velocity is 63.7 meters per second up. Because of that up, and because acceleration is down, I'm going to make it negative. And now my displacement is 100 meters. So here I want the speed for the final velocity. For the final velocity here, we're just going to use v squared equals v0 squared plus 2a delta y. So my final velocity is going to be the square root 63.7 squared plus 2 times negative 10 times delta y, which is positive 100 meters. It's positive 100 meters because it's up. We do all that, and the velocity comes out to be 45.4 meters per second, but it's a square root, and square root means plus or minus, so that means 45.4 meters per second up, or 45.4 meters per second down, so that would be negative. Reason being, we're going to go up and come down. When we're at 100 meters, we could be on the way up or we could be on our way down. Because there are two of those. There are two times when my elevation is 100 meters. So for that, when is the ball at 100 meters? Gives me two things I could do there. Time from the first equation is velocity minus initial velocity over the acceleration. So we could look at that two ways. We could say positive 45.4 minus 63.7 divided by negative 10. So my first time, the first time I'm at 100 meters, would be on the way up, 1.83 seconds. But on the way down, it would be negative 45.4 minus 63.7 divided by negative 10. On the way down, it would be 10.9 seconds. There's different information there. And then finally, part G, when will we be at our initial position? Initial position is special because my height is the same as where we started, making my delta y equal to 0. The acceleration is still negative 10 meters per second squared. The initial velocity is still 63.7 meters per second up, and my delta y is 0. We want the time. The most convenient thing here is this equation, delta y equals v0t plus 1/2 at squared. Because delta y is 0, fact over v0t, negative v0t equals 1/2 at squared. The t's cross out. So I can solve for time over here, multiply both sides by 2, divide by a, and so the time, negative 2v0 over a. Time is negative 2 times 63.7 divided by negative 10. That makes my time, the whole entire time, come out to be 12.74 seconds. Oh, great. What maximum height will be reached by a stone thrown straight up with an initial speed of 35 meters per second? The initial speed, v0, is 35 meters per second. It's up. We're talking about the maximum height, so that's going to be at the very top. At the very top, I know my final velocity is 0. And because this ball is thrown, I know that the acceleration is 10 meters per second squared down, making that negative. Well, I want to know the maximum height reached by that stone. I want to know my delta y. Well, I have velocities, acceleration, and delta y. I'm going to use this equation. So we're going to solve for delta y. Subtract over v0 squared. Subtract over v0 squared. V squared minus v0 squared is equal to 2a delta y. If I want delta y, I divide by 2a. So delta y is going to be v squared minus v0 squared over 2a. If we're going to do that with our numbers, then it's 0 squared minus 35 squared, and it's 35 squared is in parentheses. That negative sign stays there, divided by 2 times negative 10. Plugging that into our calculator, our delta y comes out to be 61.25 meters. So my maximum height is about 62 meters. Rounding thing. Number 3, a ball is dropped from the top of a building. Reading through that, dropped right away tells me that we are in free fall. We have 10 meters per second squared down. And it's dropped, so it tells me that the initial velocity is 0. In the absence of air resistance, it will hit with the speed of 49 meters per second. If I drop something, the speed that it hits the ground is also down. What's the height of the building? Delta y. Well, guess what? That's also down. If I start off on a building and I fall down, I end up below where I started. So for this question, everything is down, and I don't need to throw in any negative signs. The equation that has all four of those things in there, v squared equals v0 squared plus 2a delta y, exactly what we had before. So delta y is v squared minus v0 squared all over 2a. So that delta y is, well, they tell me 49 squared minus 0 squared over 2 times 10. So the delta y, put that into our calculator, comes out to be 120 meters, and that's still down. So that tells me the building is 120 meters from the ground. All right, number 4. A boy at the base of a tree and friends throwing water balloons at him. He wants to hit one of these students with a baseball. So he wants the ball to be moving at a speed of 5 meters per second when it hits them. Final velocity is 5 meters per second. His friends are 32 meters above the point of release of the ball. So my delta y is 32 meters up. We want to hit him in the face going up. So how fast must the boy throw the ball? That's the initial velocity. I don't know that. And we're throwing it. So it tells me we're in free fall, and the acceleration is 10 meters per second squared down. So I got to make it negative. The equation that has all of that stuff there is v squared equals v0 squared plus 2a delta y. If I'm solving for v0, we're going to subtract 2a delta y. That goes away, and I've got v squared minus 2a delta y is equal to v0 squared. So v0 is the square root of 5 squared minus 2 times negative 10 times 32. Those negative signs cancel out. We end up adding them, which is good because we want the initial velocity to be bigger than the final velocity. Get 25.8 meters per second. All right, we're moving on to the next question. The kid is going to go to a cliff and start throwing stuff off of the cliff. So, draw our situation. He's on the cliff. He throws the ball up with a speed of 20 meters per second, and it comes down. So, what we want to know is the velocity of the ball when it's at the level of the cliff. So, we know since he's throwing it, the acceleration is still 10 meters per second squared. We know the velocity is 20 meters per second squared, but that's up. The acceleration is down, so we need to make that acceleration negative. And if we're looking at when it's just at the level of the cliff, it's going to go up, and its delta y is going to be 0. It's going to be at the same level. So because the delta y is 0, that's my extra known. I know my acceleration, it's negative 10 meters per second squared. I know my velocity is 20 meters per second. The displacement is 0, and I want the final velocity. We'll use the second equation, take the square root, but since the delta y is 0, that whole second term goes away. I get 20 meters per second. Since this is a square root, I have the option of positive or negative. And if we look at what's going on, I know that as that final velocity there, it has to be down, so that's negative 20 meters per second. The next one is the velocity of the ball just as it hits the ground. So if we look at the ground, that's 30 meters below the edge of the cliff. So my delta y in this case is going to be 30 meters, but it's down. It's below the edge of the cliff, so we're going to make it negative. My acceleration is 10 meters per second squared, down, so we got to make it negative. My initial velocity is 20 meters per second. That's up, so it's positive. Got to find the final velocity. So we use the same second equation. 20 squared plus 2 times negative 10 times negative 30. And this is super important that we make it negative 30. This is going to tell us that our final velocity is bigger than 20 meters per second squared, which is a big part of this. So we put all that into the calculator, and the velocity comes out to be 31.6 meters per second. But again, since we took the square root, we have the option of making that positive or negative. We know it's down, we're going to make it negative. It's important. Now we want to know how long it takes the ball to fall. So here, the delta y is negative 30, again. The acceleration is negative 10, again. The initial velocity is 20 meters per second. Why my signs are the way they are. My final velocity is 31.6 meters per second down. So it's still negative. And I want the time. We're going to use the first equation. V equals V0 plus AT. Subtract over V0, divided by A, that gives me the time. When we plug our numbers in, that's negative 31.6 minus 20 divided by negative 10. It's important here that you have that negative sign on the 31.6 because it's going to give us a longer time because it's the end of the whole trip. It's important that it's still down. It gives me a time of 5.16 seconds. Then we want to know the maximum height of the ball. Well, this is maximum height. It's an important point. That's where the final velocity is 0. The initial velocity is 20. Final velocity is 0. The acceleration is 10 meters per second squared down. Make it negative. Delta y, we don't know. So we're going to use this because we know everything except for delta y. So subtract over V0 squared. We'll divide both sides by 2a. We're going to have room for that. And then when we solve for it, delta y is v squared minus v0 squared all over 2a. So that's 0 squared minus 20 squared over 2 times negative 10. My delta y comes out to 20 meters. That's how high above the cliff we are. That question. Next, we're going to shoot a ball straight up from the Earth with an initial speed of 19.6 meters per second. So we want to know its displacement after 1 second. We'll do all that over here. So, shot straight up. The initial speed is 19.6. So, the acceleration is 10 meters per second squared down. The initial velocity, 19.6 meters per second up. So, we're going to make the acceleration negative. And for this problem, my time is 1 second. I want my delta x. The easiest thing is the equation that has displacement equal to initial velocity times time plus 1/2 v squared. So this one doesn't have any algebra. We just plug it all in. 19.6 times 1, 1/2 times, and again, it's super important that we use the negative sign for the 10 times squared. Plugging that all in gives me a delta x about 14.6 meters, 14.7 meters. Maximum height that the ball reaches, we're going to do that here. So the initial velocity is 19.6 up. The acceleration is 10 meters per second squared down, so it's negative. Final velocity at the maximum height, that's one of our important places, going to be 0. And I want to know how far away that is. So we just solved for this before. The displacement is the velocity squared minus the initial velocity squared over 2a. So it's 0 minus 19.6 over 2 times negative 10. So put that in and it comes out to be 19.6-ish meters. Then we want to know the time that elapses between throwing the thing up and returning to its original launch point. So original launch point tells me that delta y is equal to 0. My acceleration is still 10 meters per second squared down, so it's negative. My initial velocity is still 19.6 meters per second up. I want to know the time. So we're going to use delta y equals v initial t plus 1/2 at squared. Plug in that 0 because it's really helpful to do. Means I can bring over v initial times time, just subtract that over on both sides. Goes away on the right hand side. It tells me that negative v initial times time is equal to 1/2 at squared. One of my times crosses out. Negative v0 equals 1/2 at because the time has gone away. I'll multiply both sides by 2 and divide by a. And so that tells me that time negative 2v0 over a, negative 2 times 19.6 negative 10 gives me roughly 4 seconds. There you have it.